Hello, my name is Mario Schjetnan, architect and landscape architect and urbanist, and director of Grupo de Diseño Urbano. We are located in Mexico City, and thank you for the invitation to participate in the Water Game Changers Award, nature-based water eco-technologies to enjoy the right to water and nature. Thank you very much, and it's a pleasure to be invited. In this occasion, I'm going to present several strategies and implementations of water harvesting and infiltration in some projects that we have done in Mexico City, and how we can explode this concept to different parts of Mexico City. Now that it has been a successful project of water and harvesting and infiltration, we are now studying the possibility to expand this model into the infiltration of the urban areas in Mexico City. As you know, Mexico City, Tenochtitlan, the Aztec Empire, was in the middle of the system of lakes in the island of Tenochtitlan, and they created this a system like it was called the Venice of the West, through a series of channels and chinampas and canals in the middle of the lake. The geological history of the basin of Mexico City is a volcanic process over 20 million years ago that created a closed basin, therefore creating a system of 5 lakes from north to south, and different lakes of different qualities of water. And Tenochtitlan was located here in this part of Lake Texcoco, or here, as you can see, with other islands that created a metropolitan kind of system of small cities. But the main city was of course, Tenochtitlan. This is the hydraulic map of the Mexico City basin. As you can see, all the water coming from the mountains and creating these systems of lakes. Today, Mexico City, part of Mexico City and environs and different metropolitan area is located on top of the lake, and therefore having the problems of continuous flooding, which was created many problems all the way from the 17th century to today. The solutions that were devised from the 17th century, 18th century on, it was to desiccate the lakes, desiccate the different lakes, and through channels and tunnels, taking the water out of the valley through the mountains, and therefore theoretically preventing the flooding of Mexico City. Of course, this was not possible. As you can see here from these photographs, during the 1950s, Mexico City had enormous problems of flooding, particularly in the central district, the historical district. But those floods continue today, as you can see in this underpass during the heavy rains of Mexico City. The solution is an engineer-based solution of deep drainage system that takes away the water from the rains out of the basin, out of the valley, and therefore, in theory, preventing the flooding of Mexico City. This system started in the 70s of the 20th century, and it took, we can know, about 17 years to be constructed. and still very recently was constructed one of the final enormous tubes or pipes that were excavated under the mountains in order to take away the water system out of the valley. As I say, an engineer-based concept which has created enormous problems for the city. Right now, we are extracting about 2/3 of what is incorporated into the aquifer by storm water and rainwater in the valley. So, in other words, we have a problem that if we do not resolve during this first half of the 21st century, probably Mexico City will not have a future. We have to resolve this, the infiltration of water, the stabilization of the aquifers of Mexico City. As I say, we are extracting more water, we are evacuating more water than it is being precipitated or reincorporated into the aquifer of Mexico City. This has created enormous problems, first of flooding, but also of subsidence of the buildings of the downtown. We have the extracted water, and in some areas of Mexico City, the subsidence is up to 1 foot per year. That is a big problem because all the drainage system, all the infrastructure of pipes and so on that were designed or created or constructed during the late part of the 20th century, of course, are now against the levels of that were originally designed. Around 2004, we were invited to participate in a project called Tecnoparque. Tecnoparque is located in the north portion of Mexico City, in the border of Mexico City with the state of Mexico. It's the continuous metropolitan area, but basically this is the border of Mexico City with the state of Mexico. This site of about 14 hectares in total was originally a factory for the production of steel and rod. And this was closed around the 90s of the 20th century because of the contamination of the air contamination of the city. So in 2004, we were called to design a master plan to develop a project of offices related to call centers, data centers, and service centers for the metropolitan area of Mexico City. And we participated in this master plan and in the construction of the infrastructure of this development. The conditions to change the land use from industrial to offices, housing, or commerce were with the condition that the city would not give the site more potable water. They would only give potable water enough of what the industrial area or industrial site was authorized, and the city forbid us to connect the rainwater and the black water, the drainage water of the development to the drainage system, to the municipality drainage system. So the whole system had to be resolved in situ on the site itself. How? Through infiltration and also to recycling. Well, we can see here the Rio de los Remedios, which is the main channel for the evacuation of water in this district. And as you can see, it's completely saturated and it has overflowed many times. So that was why the city didn't allow this development to be connected to this system, to this river or channels. So the project had to be developed by a process. So we did a master plan from 2004, and it took us about 10 to 12 years to develop the whole project altogether. This was the first stage in 2004, the second stage in 2010, and the third stage of the buildings in 2014, in 2018. In addition, a service area, a small commercial center was developed also on the site. The creation was with a system of square buildings, and these buildings were to be resolved by the harvesting of water and infiltration of water into the aquifer in situ. So this is a zero outflow of torrential waters into the municipal system. This is the system today. It's finished. It's a very successful development in terms of offices and service centers, data centers, etc. Okay, well, how we worked on this process is to first capture the waters from the roofs, harvesting here, and then projecting the waters into rainwater cells, into cisterns here, and then projecting the water sent into deep water wells, more or less at 50 to 60 meters down into the ground at about the areas of absorption or infiltration. The second system was to have water from all the restrooms and kitchens of the development to water treatment plants, and then these were directed to water landscape pools for storage and recycled waters in order to have irrigation of the green areas of the site. So this is the system of cisterns, cells, capturing the water from the roofs and then putting it into a final cell with activated carbon filter, and then into the infiltration well down to 55 meters down into the absorption of the aquifer. The cistern then was covered with concrete slabs, and then on top of that, the slab creates a water pool out with incorporating the treated water, the water treated from the bathrooms and kitchens, and then used for irrigation of the site. We can see here, then going back to the master plan, that three of these systems of lakes and cisterns were constructing during this 10 to 14 years site. In conclusion, the rainwater storage is underground. The recycled treated water for irrigation is on top of these slabs, creating these beautiful pools, landscape pools, which capture the beautiful landscape of the site. We created gardens, we created seating, we created cafeterias around these lakes for the enjoyment of the 12,000 users of this master plan system. This is one of them. So as you see, this is a cafeteria, community center, the buildings, which also have cells for electricity, and then under this pool, there are a series of cisterns as described in the diagrams before. Again, this is the very first system between the two buildings. We created three different pools and systems of parks, let's say, around office buildings. Basically, the system is this: harvesting, then the cistern, filtration, and then infiltration into the aquifer, and that we are able to infiltrate up to 90 liters per second in a storm in each of these wells. So we have 9 wells for the whole development, and we can then we're injecting about 900 liters per second into the aquifer on a big storm, and then little by little the cisterns release the water into the aquifer. We have done this system also in a new park done in Mexico City. You can see out of these roofs in a pyramidal system, which capture the water. The water is then sent to the same system. They capture the water. As you see, this is the filtration system, and then the whole water is again infiltrated around 50 meters down into the absorption of the aquifer. So how do we extrapolate these models, these two models done in the same district of Mexico City? And what are the problems that have? We cannot separate one of these problems. It is an integral problem system. It's a system to restore the water balance of the basin of Mexico City. We start with creation of forests and parks, harvesting and water collection, infiltration systems, recycling of treatment waters, equity and sustainability of fiscal systems, and finally, distribution and of the wealth. Also, this what we call the hexagon of water, in order to solve the problem, there have to be 6 simultaneous actions and strategies to restore the basin's water balance, including the solving of water spills in the water system. Mexico City loses around 20 cubic meters of water per second out of spills from the water system. Okay, so Mexico City, here we have the isoyates of Mexico City, and we have an average of rains a year of 750 millimeters per year. That is a lot of water that comes and rains in Mexico City. The problem is that we have this in storms during basically the summer and part of fall. So we have a lot of water coming into half of the year, and the rest of the year is a drought season. We have only 2 seasons, the drought season and the humidity season. So You can see here the average precipitation of Mexico City is 750 millimeters of water along the year. And we can have rainstorms in 1 hour of 76 liters per second in a big storm. So the storms come very strong during the winter and summer. So where there's flooding, there's very little infiltration, and this is the one of the main problems. So again, looking at this, we are harvesting the water. We are infiltrating water first with natural small dams along the mountains, and then the problem of the artificial, how do we do by eco technologies like wells and so on to infiltrate in an artificial way down to the aquifer. So we have expanded the model, and the model is okay, if we have a clean roof of 1,000 square meters, then we can build a water down pipe to a cistern of 160 square meters at about 9 meter size by 2 meter deep. And this would get a storm of 1 hour would be harvested. Or it could have, this is a 24 storm, and then that would be a storage to release water little by little into the aquifer. Then the third portion is the infiltration well. There's a cylindrical excavation and placement of pipe with perforations, and it's aimed for water harvesting infiltration in 24 hours. Drilling a pipe diameter of 100 centimeters in diameter, we can construct a steel pipe of 60 centimeters. And we have found that in Mexico City's geology, we have two permeable stratums, one at 50 meters down, and then another one at 80 meters down. So these are the possible areas to have infiltration into the aquifer of the geology of Mexico City. These are the geologies, as you know. Of course, we were in a lake. The lake, these are soils. These are clay soils, and then we have sand soils. But then this permeable stratum is composed of volcanic rock, and then it can infiltrate water into the aquifer. We have defined that in the old part of what used to be the lake, basically the orange part, and the red part is where the city was constructed over the lake. So this is areas or this is the old lake system, and the red one is the transitional area of soil classification in Mexico City. So zones 2 and 3 are the most prone or possible infiltration, and permeable strata are located between 50 and 80 meters deep. What is very interesting of this process, all of this area, again, like I have said, is urbanized, and is the most areas which is the most problematic in terms of flood. But it's also the most areas where we are extracting the water from the aquifers. So we do have to infiltrate the water, yes or yes. So we have done a study that there could be 4 million square meters of flat roofs of over 1,000 square meters. The amount of infiltration we could have if we extrapolate the model of Tecnoparque, we could extrapolate this to 4 million square meters of flat roofs of over 1,000 square meters in Mexico City. We could be infiltrating as much water as we are extracting right now if we implement the system at the level of the urban area of Mexico City. But we could even improve this more in the areas outside of Mexico City, in the rest of the metropolis of Mexico City, in the areas of the state of Mexico. So this is only one aspect of the balance of hydraulic balance of Mexico City. As I said, there are other 4 elements which had to be planned and executed in order to have a balance and in order to have a future for Mexico City. Thank you very much, and I hope you find this interesting.